You'll find that inequalities, as before, whether it's regular or composite functions, you'll be able to explain using graphs. You'll be able to visualize it. You'll be able to explain using t-charts like, x and y. You'll also be able to explain it algebraically. That's the main goal. So today, I'll show you what it means to explain it algebraically, so you can prove yourself nonetheless, and it should agree with what we draw visually, and away we go. Any questions about what we're doing today? Okay, let's get started. Visually speaking, if my question for you is this. For what set of values is f of x bigger than or greater than g of x? Long story short, what is the value, for what sets of values is the y value of the f function f greater than the y value of function g? In other words, visually, when is the parabola above the straight line? Should quickly explain in words where you might see that happen.
Is it the top point or is it anywhere above it? Is it something diagonal?
That's f. It goes on forever. And this is, of course, the y value of f goes on forever, right? As x increases, y increases, and x decreases, y decreases. So far, so good? This is my parabola. Is it above my line?
Yes.
This is my parabola. Is it above my line? No. That's all I'm asking. You don't have to, confuse yourself with it's going on forever. Just looking at the graph. Which sections in this graph, in this entire picture, is a parabola above the straight line? That's it. Yes?
Negative can be the square.
Okay, so assuming this is a normal parabola, that would be -1 all the way to. Okay, so we are not looking at this point, okay? Not here. We are looking at all of that, and of course, all of that. Okay? So if we do this algebraically, we should show that anything above the x value of 2 and anything below the x value of -1 falls under this inequality. Makes sense? Okay? We're just trying to tell a story. It's not mathematical per se, we're just trying to figure things out, right? And why is this such a big deal? Well, it's pretty boring because we only have like x squared and x plus 2. But if both of these, just like the example I mentioned, if they're representing things like profit and cost and whatever, okay, all of a sudden it gets interesting, right? Do we want to be in the red? Do we want to lose money? No. So it's in your best interest to know what is your success point. Anything under this, you're losing money. Anything above this, you're gaining. So you have a specific goal, let's say, every month. You have to make like 2 sales every month. I don't know. Just an example. Algebraically, how do we show it? Anyone remember how we might deal with this statement?
Do we have to make a little
What is this?
chart? What is it, chart?
I want us to graduate from that. There's nothing wrong with it. However, the chart, if you do a chart, you see a trend, right? Because you see like you're going to plug in 1, plug in 2, plug in 3, plug in 4. You'll see a trend, but it doesn't give us the full picture. It only gives us only up to the point that you have plugged in. Okay, so I'm looking more for an algebraic solution. How do we solve this? You remember from previous chapters?
Move one of those to the other side. So
So what do you notice? We have an x squared here, x plus 2. If you're trying to figure out what value of x makes this true, you might want to turn it into a quadratic that allows you to solve for a 0. And you remember that for zeros, for solutions? No? Got it. Let me do the first one for you. I'm going to bring everything to one side so that the other side is going to equal a 0. So I essentially have a new parabola, and I want to know when this parabola is going to be above the 0 mark. And it makes life easy for us if we do that. You could guess and check, but why do that if there's a simpler, more accurate method? From here, so therefore, my zeros are
+2, negative.
or negative 1. Do I have any vertical asymptotes? No. Do I have any holes? So, all we have to do is pick up those two. Ring any bells? Look familiar? Plug in all vertical asymptotes and all zeros, which is all we need. I'm going to plug in any number under negative 1. So let's plug in like negative 1,000. Negative. Negative. So this is going to be on the positive side of things. Plug in a number between negative 1 and 0. The easiest number I could think of is 0. 0 minus 2. 0 plus 1. We have completely negative. And from 2, I'm going to put in 1,000. 1,000 minus 2 is a plus. 1,000, that's a plus. This is a plus. So, when is this greater than 0?
When it's less than 1, negative 1, and bigger than 2.
Do I count this and that as part of my solution? The answer is no. If this was a negative 1, this entire thing equals a 0. Do I want it to equal 0? No. So in other words, from here, does that make sense? X is going to belong to, of course, real numbers, such that X belongs to, let's see, not including negative 1, sorry, from negative infinity to negative 1, but not including negative 1, union 2, not including 2, to positive infinity.
Union just means and, right?
Yes. Okay? Which makes sense. According to my picture, anything under negative 1 is a place I want to be, or anything above positive 2 is a place I want to be.